And here, this is note of RIP. So what I am saying, RIP stands for Routing Information Protocol. It is a distance vector routing protocol. It works at layer 7. AD value of RIP is 120. It uses UDP at transport layer, and it uses hop count as a metric. After that, the largest number of hop allow in RIP is 15. Means only 15 hop are allowed in RIP. So it limits the size of network that RIP can support. Getting my point? Means let me design one topology here, guys, in Paint. This is also one disadvantage of RIP. Here it support only 15 hop. Router 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. I am connecting how many routers? 16 routers together like this. Okay, guys. Now question is, this router have one network, let's say 192.168.10.0/24. This router have one LAN network over here. So this router will advertise this network information to their neighbor. Yes or no? To this router, what will be the metric over here? Hop count 1. Yes or no?
Yes.
Right? Metric for this router, when this router will advertise to this router, metric will become what?
2.
2. When this router will advertise it to this router, metric will become 3.
3.
Here metric will become 4. Here metric will become 5. Here metric will become 7. Here metric will become 8. Here metric will become 9. Here metric will become 10. Here metric will become 11. Here metric will become 12. Here metric will become 13. Here metric will become 14. Here metric will become what? 15. So when this router will advertise this network to last router, metric will become what?
16.
16. That is not allowed in RIP. It can support maximum 15 hop. So network size of a RIP protocol can be up to 15 router only. Getting my point? So 15
Yes.
hop above network will be considered as unreachable. Means for this router, from this router, let's say this is my R1. From R1 192.168.10.0/24 network is unreachable. It will router 1 will not accept the update from their neighbor with metric 16. Maximum metric that allowed in RIP protocol is 15 only. It can support up to 15 hops. Is it clear?
Yes.
Yeah, it's clear. It means like RIP cannot support more than 15 routers.
Yes, more than 15 routers. RIP cannot support more than 15 routers. So you can see, if I have large network, like if we have more than 16 hops or let's say 100 hops, we cannot configure RIP there.
Okay.
Okay.
Yes.
And this is also one disadvantage. We cannot say it is advantage. Yes or no? After that, a
Yes.
split horizon. You know what is a split horizon?
Split.
No, I don't know.
You don't know? See, a split horizon is a loop avoidance rule. I have one daughter over here, R1, and one more router is here, R2. Done. Both router are directly connected like this. This is my R1. R1. This is R2. Here this is, let's say, 0/0 F 0/0 interface, and this is also F 0/0 interface. Done. Now router 1 have one network, again let's say 192.168.10.0/24. Okay. So what router 1 will do? Router 1 will generate one update message. In this update message, it will share this network information 192.168.10.0/24. Yes or no? This is update message of router 1. Update. Till here, is it clear? Definitely router 1 will generate one update message, and through that update message, it will share this network information to router 2. Am I right?
Yes.
When router 2 will receive this update message, it will install this network in their routing table. 192.168.10.0/24 is reachable via router 2, or IP address of router 2 is, let's say, 12.1.1.1. This is routing table of router 2. It will install this network information in their routing table. When router 2 will receive update message, it will install this network in their routing table. Now guys, tell me, is it responsibility of R2 again to share this network information to their neighbor? So router 2
No.
will share same network information to router 1 also. Yes or no?
Yes, that's correct.
It will also generate one update message, and in that update message, it will share 192.168.10.0/24. And router, see, on router number 1, update message. On router number 1, earlier router 1 was sending same network information from fast Ethernet 0/0 interface, from this interface. And now router 1 is receiving same network information on this interface. Yes or no? On the same interface. So this is what? Loop. This is loop. I am telling you that, brother Abdul, if you want to learn CCNA, let me know. I know CCNA, I can teach you. And you are repeating same information to me. You are also telling me, if you want to learn CCNA, let me know, I can teach you. So this is loop. Don't you think it is loop? Isn't it, guys?
Yes, clear.
So this is loop. This is routing loop. In distance vector routing protocol, we have a feature to avoid this loop called a split horizon. It is a feature of distance vector routing protocol, a split horizon. And by default, a split horizon is enabled on all interface of router. By default, it is enabled on all interface of router. This feature or this rule said that whenever you are receiving an update on an interface, you will not share that update from receiving interface. Let's say router 2 is connected with one more router R3. So definitely router 2 will share the update message which router 2 is receiving on this interface. It will share it from this interface, but it will not share same update from receiving interface. This is rule of a split horizon. Getting my point? If you will type it on Google as well, that what is a split horizon, what is a split horizon, or we can say a split horizon in RIP. So see, what is a split horizon? What is a split horizon? A split horizon is a method used by distance vector routing protocol to prevent network routing loop. The basic principle is very simple. Neighbor send routing information back in the direction from which it was received. It is clear?
Yes.
Okay. So let me design one topology as well in GNS3 to make you understand this feature. This is feature of distance vector routing protocol. In upcoming day you will understand sometime we need to disable this feature, or sometime we need to enable this feature to avoid the loop. So first understand what is speech horizon service feature, then only you can understand in which scenario I need to off this service and in which scenario I need to use this service. Router 1, router 2, and let's say again I have one more router, that is router 3. Now I am not using router 3, let's say I have only two router 1 and router 2. Let me keep router 3 somewhere else. Done. And here I am connecting one switch. Here also I am connecting one switch. Let me connect the devices. Let's say this is my topology. Guys, yesterday in last class also we had discussed one feature, that is actually RIP was sending update message from LAN interface also. It was sending update message from LAN interface. Which interface is LAN interface here in this topology? Can you tell me the interface of LAN?
F1 is
F1/0 here also and here also F1/0. Do you think router need to send any update message from this interface, guys?
No.
No, this is unlogical. Yes or no? Here we don't need update message of RIP. RIP is used to share routing information between routers. So if you want to stop the update message of RIP on LAN interface, what is solution? Solution is, yesterday we had discussed this solution.
Yeah.
Passive interface. Passive interface. We can configure F1/0 as passive interface. And once you will configure one interface as passive, router will consider that interface as LAN and it will not send any update message from there. First of all, let me configure this topology. On router number 1, let me configure the IP config T and interface F0/0. I am going to use IP 12.1.1.1, IP address 12.1.1.1, 255.255.255.0, and LAN interface I am running, let's say IP 192.168.10.0, 255.255.255.0. Say no set. Done. I've configured the IP address on router number 1. Let me configure IP on router 2 also. Config T, interface F0/0 no set, and IP address is 12.1.1.2, 255.255.255.0. Exit interface F1/0. Here I am going to run network IP 192.168.20.1, 255.255.255.0. Done. Now I am going to configure the RIP. So as you know, to configure RIP I need to run some command. First command is router RIP. After that version 2. As I told you, we never use version 1. Okay, so you will always define version 2 because RIP version 1 does not support VLSM. RIP version 1 does not support subnetting, but RIP version 2 can support VLSM and subnetting. That's why we are using RIP version 2. In RIP version 1, update message was sent on broadcast address, but in RIP version 2, update message will be sent by router on multicast address. Okay, and as you know, by default auto summarization is enabled, so I need to run command no auto summary to disable automatic summarization. After that, with the help of network command, we can enable RIP. So network 12.1.1.0 and network 192.168.10.0. After that, if you want to see this router is forwarding update message from which interface, so you can use one service of router, that is debugging. We have one service on router, that is debugging. With the help of debugging, we can check the log message of any protocol. Like I want to check log message of RIP protocol, so I can enable debug IP RIP event. I can run this command to enable the log message of RIP. By default, it is not generating any log message. After running this command, it will show you the log message. After 30 seconds, it will generate update message. One update message from fast Ethernet 0/0 and one update message from fast Ethernet 1/0. See, it is sending RIP sending version 2 update to 224.0.0.9 via fast Ethernet 0/0. So it have sent one update message from fast Ethernet 0/0. Yes or no? Yes or no, sir?
Yes.
And it will send one update message from fast Ethernet 1/0 as well. So you can see here 0/0, it is not sending from F1/0. Let me check. So IP interface brief exclude unassign, that interface is up or down. So IP interface brief, oh, F1/0 is down. Interface F1/0, say no set and IP address 192.168.10.1255255.255.0. Now wait, it will send update message from both interface. See, it is sending one update message on F0/0 and one on F1/0. Yes or no? It is sending update message from both interface. But I don't want to send update message of RIP from fast Ethernet 1/0. So I will configure 1/0 as passive interface. How? In router RIP, just you need to run command passive interface. After that interface type 1/0. Done. Now you will see it will not send any update message from F1/0. See, it is sending update message from fast Ethernet 0/0 only. Okay. Okay, guys.
Yes.
And how to verify
Yes.
passive interface configuration on router? By running command show IP protocol. In show IP protocol, you can verify it. See, I have configured one interface as passive interface. Passive interface. Which interface is passive interface? Fast Ethernet 1/0. Done. Now I am going to configure RIP on router number 2. So here also I am going to say router RIP, then version is 2, then no auto summary, and then network 12.1.1.0 and network 192.168.20.0. Done. I have enabled RIP on router 1 and router 2 on both interface. Here also on router number 2, F1/0 should be configured as passive interface. So let me configure passive router RIP and passive interface fast Ethernet 1/0. This is very important configuration. Whenever you will configure RIP, you need to configure passive interface to LAN interface, so that router should not send any update message. Done. Done. And on router number 1 we have enabled debugging. So if you want to disable it, you need to run command unall. Unall. See, all possible debugging has been turned off. Now it will not show you any log message of RIP. Done. And so IP route RIP, so it have received this network 192.168.20.0 from router number 2. Next hop is this one. So I can ping 192.168.20.1 and source is 192.168.10.1. means 10.1 is able to ping 10.20.1. Yes. Yes.
Yes.
And so one more command, so IP interface F0/0. By running this command, here we are able to see one thing. See here, okay, this interface is joined this multicast group. Yes, very good. This is the multicast address of RIP version 2, and a split horizon is enabled. By default, speech horizon is enabled. Okay. So if you want to disable a speech horizon, command will be very simple. So a speech horizon is enabled by default, means when, see, router 1 have one network, this network 192.168.10.0/24, right? So router 1 will share this network information to router 2. It will share 192.168.10.0/24 to router 2, and by default speech horizon is enabled on F0/0. So router 2 will not send this network information back to router number 1. Yes or no? It will not send this update message. Otherwise, if I will disable a speech horizon over here, router 2 will send this same network information to router 1. Okay, and how to disable it? Command is again very simple. On interface F0/0, you will run command no IP split horizon. This is command to disable a speech horizon. Now if you will run command show IP interface F0/0, so you can see a speech horizon is disable. Okay.
So we know how to disable it, right? We
Yes.
should keep it enabled.
By default it is enabled,
It is enabled, yeah.
and you need to, sometime you need to disable. In this scenario it should be enabled, yes or no? Otherwise
Yes.
here loop can form. Yes or no? Sometime you, now if you will see, if you will debug router 2, here I am going to say debug IP rip event. On router number 2, see speech horizon is disabled over here, so it will send this network information, same network information which router is receiving from router 2 to router 1, router 1 to router 1. See, it is sending one update message to 12.1 from fast ethernet 0/0, one update, and in that update it will carry 192.168.10.0 also, 20.0 as well as 10.0. But it should not include 10.0 because router 2 have learned this network from router number 1. So why router 2 will send it to router 1 again? Yes or no, guys?
Yes.
So I will enable speech horizon. So where speech horizon should be enabled or disabled, that depends on the scenario only. Okay, we will discuss the scenario where you need to disable it. But in this scenario, speech horizon should be enabled. IP split horizon. I have enabled it by running this command.
Okay.
So IP interface F0/0. Again, you can see speech horizon is enabled. Done, guys.
Yes.
So these two feature, passive interface and split horizon, should be clear to you. And you know, this is a not only feature of RIP. This is feature of EIGRP also. In EIGRP also, we have same concept of speech horizon. In EIGRP also, by default, speech horizon is enabled, and if you want to disable manually, you have to disable it. And passive interface configuration is also same in EIGRP protocol also. Okay.
Yes.
So this is concept of a split horizon. After that we have timer, as you know, update time, invalid time, flush time, and hold on time. So update time is 30 seconds and hold on time is 180 seconds. What do you mean by it? It means that whenever router 1 will send any update message to router 2 will hold that network information for 180 seconds. See guys, I am giving some information to someone. I am giving some information to someone, and their hold on time is, let's say, 100 seconds. That means the receiver who will receive my information will hold that information for 100 seconds. Yes or no?
Yes.
So if router 1 is sending the update message, router 2 will hold that network information for 180 seconds. and after 30 seconds again router 1 will send same update message. So it will reset the hold on timer after every 30 seconds. But if for 180-second router 1 will not receive any update message from router number 1, so it will discard it. Okay,
Yes.
timer will work like this only. Then these are the command to enable RIP routing protocol. Then we have some difference between the version 1 version 2. As you know, update address broadcast in RIP version 1, but in case of RIP version 2, update address not broadcast, it is multicast. Update address, here it should be multicast. 222.4.0.0.9 address. It is in class full routing. Class full routing means it does not support VLSM and subnetting, but RIP version 2 is an classless routing protocol. So it does not support VLSM, it support VLSM. Here in RIP version 1 we cannot configure authentication also. Authentication means password. But in RIP version 2 we can configure authentication as well. Okay. After that we have some drawback of RIP, like hop count. So maximum hop count allowed in RIP version 1 is 15 only. So this is also one drawback. After that, metric, as you know, metric is hop count. So it not use link property to calculate metric, link bandwidth. So this is also one problem of RIP. Okay. According to RIP, closest is always best, but it is not necessary that closest is always best. Shortest path is not always best path. Let's say this is your home. Let's say this is home of Abdul. Abdul, you are living here, right? And from your home there is one market. This is a market, and you have two ways to reach market. One way is this one, and one way is here. Here, bandwidth of this road is very high, and bandwidth of this way is very less. So distance of this link is let's say 1 kilometer. This road is 1 kilometer, and distance of this road is 1.5 kilometer. But bandwidth of this road is high. Because of that, when Abdul want to reach market, this road takes let's say 10 minutes, and this road takes 20 minutes. So which road is best according to you? Lower one or upper one?
The lower one.
Lower one, definitely. But according to RIP, this path is shortest path. Distance is only 1 kilometer. So according to RIP, this path is best path. Yes or no?
Yes.
Yes.
So this is also one drawback of RIP. RIP always think closest destination is best.
So
Okay.
RIP is done like hub.
Not like hub. Hub is a different thing.
No,
Hub always do broadcast. That is disadvantage of hub.
No, I just
Yeah,
compare with
it's stupid like hub, but it's not.
it's not. Yeah, it's not.
Yes,
doing
it
like
is
that.
as
This
stupid
protocol and
like
hub is
hub.
like, yeah, it's not smart. RIP is not,
Not as
smart.
smart. Yeah. And then slow topology converge as well. Periodic update is sending periodic update, right? Let's say I need to tell you that I know CCNA. Okay. So just I need to tell only once. There is any logic after every 30 seconds I am telling you I know CCNA, I know CCNA, I know CCNA. No. Yes or no? But RIP router send update message, same update message after each 30 seconds. This is also one drawback, because it can increase the traffic, network traffic. Okay. So these are drawback of RIP. That's why we come up with next routing protocol, that is
This is nice.
Okay.
JP.
okay, guys.
Yes.
Now just give me 1 minute, then I am starting it. Now we have some more concept in RIP, like filtering. So let me make you understand filtering as well, then I will start EIGRP. Okay.
Okay.
These are advanced things, so please try to understand. Okay, just give me 1 minute first. Okay, now let's say on router number 2 I am going to create some loopback 10.1.1.0/24, 10.1.2.0/24, 10.1.3.0/24, and 10.1.4.0/24. I'm going to create this loopback on router number 2. Let me create this loopback first. Config t interface loopback 1 and IP address is 10.1.1.1.255.255.255.0. Interface loopback 2 IP address is 10.1.2.1. Interface loopback 3 IP address is 10.1.3.1. Interface loopback 4 and IP address is 10.1.4.1. I've created this loopback on this router, right? If you want to verify, so IP interface brief exclude unassign, you can see I have created this loopback, and now I am going to advertise this loopback in RIP. So I can run command router RIP and then network 10.1.1.0, 10.1.2.0, 10.1.3.0, and 10.1.4.0, right? 4.0. So it will advertise, router 2 will advertise this all network to router number 1. Yes. And if you will check routing table of router 2, see router 1 is receiving these all network. Yes or no?
Yes.
And guys, just try to understand one concern. Router 1 never forward traffic in this network 10.1.3.0. Router 1 never need to forward traffic in this network. Let's say this is department of sales. This is one department, sales department prefix. Sales department. And router 1 never need to communicate with sales department. So unnecessary, why router will install this prefix in their routing table? Yes or no? If router never want to need to communicate in this network, so I should filter this network here. Am I right?
Yes.
So what I can do, I can filter this prefix by creating one access control list. You will understand access control list in upcoming days. For now, just I'm creating one access control list to define this traffic as interesting traffic. On router number 1, just I am going to make one traffic as interesting traffic so that I can filter that traffic. So here I am going to access list, deny, and 10.1.2.0. I have created one access control list. In this access control list, I am denying this traffic. After that, wildcard 0.0.255. That's it.
Why you put 10? Access list 10?
Access control list, after that access list number. You will understand access control list in upcoming days. Don't worry.
No,
Just for now, just think that I have used one feature to deny this traffic on router number 1. Okay.
Yeah.
Now it will not work until and unless I will not apply this access control list in RIP. So let me apply it in RIP. Router RIP, and then I can use one feature, distribute list. Distribute list, after that access list number, and then in which direction you want to apply it. Done. I have applied it in direction, and so IP route RIP. Now you can see these all prefixes are there. All prefixes are there: 10.1, 10.2, 10.3, 10.4. 10.2 should filter from here. So what I am going to do, I am going to down interface F1/01, say shutdown, and then no shutdown. And so IP route RIP. It will receive all prefixes soon. Wait for 30 seconds.
It's not set here.
So IP route RIP. So IP dot rip. So IP interface brief exclude and assign. I think my interface is still down. F0/0. No, this interface is up, so it should receive rip. Now you can see it have receive all the prefixes except which prefix 10.1.2.0 means I have filtered one prefix from here from the routing table of R1, that is 10.1.2.0. Yes or no?
Yes. Can you do one more? Can you filter one more, because that one was a little bit mixed.
Yeah, you tell me which prefix you want to filter.
10.1.3.0.
3.0. So I need to create one access control list. Access list. Let's say this time number is 20 and deny 10.1.3.0. After that wildcard mask of this is this one. And access list 20 permit any. Okay. So you will understand the configuration of access list later. Don't worry. Okay. This is our topic. And now I am going to use this access list in router rip. Router rip distribute list. We have one feature distribute list for the route filtering. After that I am going to call which prefix list 20 and then in which direction, in direction. Okay. And so IP route rip. It will filter this prefix also. Let me do one thing. Let me down this interface once and let me say run no such command again. And now so IP route rip. See 10.1.3.0 is filtered.
Yes.
Okay.
Yes.
So this is also a features in the version 2 that we can use to filter some prefixes. In real time, it can be our scenario like router is receiving lakhs of prefixes from their neighbor, and out of lakhs of prefixes, let's say router don't need to communicate with thousands of prefixes. So we need to filter those thousands of prefixes. Okay.
Got it. Yes, sir. Did you send us this file?
Which file?
The one information about the RIP.
This
PDF.
file?
Yes, this one.
I have already shared this one, brother, through your mail.
I didn't find. I don't know.
Please share your mail ID again. I will share the study material, complete study material. Or if you need, I can share it in WhatsApp group also. Let me share it in WhatsApp.
I have the one CCNA, but I couldn't find this file.
Okay, I am sharing here also. A dynamic routing. This is the file. See.
Send it in group. Okay.
Yes. Now guys, we don't have anything in RIP. These are the all concepts which you need to learn about RIP protocol. Okay. Now before starting EIGRP, if you want to learn access control list first, let me know. I will start access control list first. Because there are some use of access control list in EIGRP or wildcard mask. Wildcard mask is also required. So first we need to understand two topics, access control list and wildcard mask. So let's start from wildcard mask. First of all, let me make you understand what is wildcard mask, because there is use of wildcard mask in EIGRP. So topic is very simple.
Just make sure, sir, you start record.
Recording?
Yeah, make sure the record is on.
Yes, recording
Okay.
is on.
Okay.
Wildcard mask. Guys, wildcard mask is just opposite of subnet mask. Opposite of subnet mask. On Google also, if you will type what is wildcard mask. What is?
There is just extra.
Yes, wildcard mask. Wildcard masks are used to specify a range of network addresses. Guys, first of all, tell me what is the user, what is subnet mask? Who will explain subnet mask?
Yeah,
Subnet mask.
divided large network to small networks.
No, subnet mask is different. Subnet mask tell us that actually, see, here I am writing one IP address 192.168.10.0 and subnet mask is 255.255.255.0. This is the subnet mask and this is the network ID. Yes.
Yes.
Actually, this subnet mask is telling me how many network bits are there in this network ID. Yes or no?
Yes.
Subnet mask identify how many network bits are there and how many host bits are there. This is 1 means network bits and 0 means host bit. 8 plus 8 plus 8, that means total 24 bits are network bits and 8 bits are host bits. Okay, is it clear, Abdul? Soha, is it clear?
Yes. Yes.
To everyone? Yes. Subnet mask tell us how many network bits are there and how many host bits are there in a particular IP address.
So what is that one? Like we just studied before, like we say, like they divide it to large network.
That is subnetting.
Oh, yeah, the subnetting. Okay.
If I am writing one IP address over here 10.1.1.1 and if I am not giving you any subnet mask, can you tell me how many network bits are there?
Yes.
How many network bits are there?
So we can use a group like it's in
Yes.
A, B,
Which
C.
class?
This class
Yes,
A.
yes. Class A. So
We have-
it have 8 network bits.
Yeah, we have 8 network bits.
But if I will define here 255.255.255.0, that means we are defining there are total 24 network bits.
Yes.
Yes or no?
Yes.
Means this is my subnetted network. Okay. Now wildcard mask is opposite of subnet mask. Opposite of subnet mask. So if subnet mask is 255.255.255.0, so wildcard mask will become 0.0.0.255. Getting my point?
Yeah, so all the network will goes to 0.
Yes,
and-
all 1 network bits will become 0 and
host
all 0 will become 1.
one.
This is wildcard mask. With the help of wildcard mask, actually we specify how many bits I need to match. How many bits I need to match. Means with this wildcard mask, we are telling to router, you need to match 24 bits. 0 means match bit. You should match, and 1 means ignore bit. You should ignore it. Okay, guys. So if I am writing wildcard mask 0.0.0.255, that means I am telling to router you need to match these 3 portion octet and you need to ignore this one. Okay,
Yes. Clear.
clear? So here wildcard mask, let's say I have one subnet mask that is 255.255.255.128. What will be the wildcard mask of this subnet mask, guys?
It should be 0.
0, the 0,
Dot one.
the 0.
120.
We have
Dot?
to.
255.
Not
hold on.
255.
No.
Um,
It's gonna be 01111.
See, here if you will convert this value, this subnet mask into binary,
It's 255 minus 128.
what will be the binary of
127.
21? First of all, tell me that. What will be the binary of
127,
128?
is it correct?
Yes.
1000.
This is binary of 128. So in wildcard mask, we will convert 1 into 0 and all 0 into
1.
1. So 3, 4, 5, 6, 7, 8. Done.
No, it should be 254.
It should be what? 254.
127.
Yeah.
No, 127 value.
64 plus
254.
32 plus 16 plus 8 plus 4 plus 2 plus 1. Yes or no?
Yes.
Right? Because 128 is 0. This is 128 and this bit is
0.
0.
Yeah, it's 254.
So total value, what value you will get over here? Not 256, 254. Can anyone add, guys, this value?
Yes, give me a second.
Yes.
96 plus 16 plus 8 plus 4 plus 2 plus 1. What value we will get over here?
127, I think.
No, it should be 254.
No, not 254.
Not 254. Hold, let me to count it.
Count it.
127.
It's
127.
easy, 'cause we just have 128. 255 minus 128.
Yeah, that is also a formula, right? So wildcard mask of this subnet mask will become what? 0.0.0.127. Okay. Or formula is
What did you do, Soha?
subnet mask is 255.255.255.128. I need to find the wildcard mask. So here it is clear. Wildcard mask will become what? 0.0.0. And here we can subtract 255 minus 128. Actually, here also you are subtracting 255 minus 255, 255 minus 255, 255 minus 255, 0. And 255 minus 128 will become what? 127. Yes. Is it clear to everyone how I am calculating wildcard mask?
Yes, clear.
Okay, let me give you one more subnet mask here. 255.255.255. Let's say 252. What will be the wildcard mask of this subnet mask? 0.0.3. 3. Very good. Now it is clear to, I think, to all of you.
Yeah, if
Okay, I'm writing 255.248. Here, what will be the wildcard mask?
0, 0, 0,
255
4.
minus 248.
7.
Mhm.
7.
4, 7,
7.
7. Oh, yeah, 7.
255 minus 248.
Yeah, that's right.
7. So this is wildcard mask. Okay, in this wildcard mask, we are telling, see, to match 8 bits plus 8 bits plus 8 bits, and then how many bits?
0.
Then how many bits I am telling to match, not 0.
7. To match?
To match. How many 0 are there here? How many 0 are there?
1.
In here, how many
Yes, in
zero?
this 7.
Hold on.
Yes.
Hold on.
No. We have to check.
1.
So 50, and
We
then
have 6 0, right?
no 50 and
5
3.
0.
Yeah,
Yeah,
50 311.
3 1.
So
Not
how many
3, 1,
0
1.
are there?
5.
0 means match. Means 5 here. That means I am telling 8 plus 8 plus 8 plus 5.
We just have
29
4, 2,
bit.
1,
Router should
0.
match how many bits? 29 bits. Is it clear, guys?
Yes.
Everyone?
Yes.
Yes.
Okay. So now I have one router. In EIGRP, we will use wildcard mask to configure EIGRP. Let's say this is a router. And this router have some interface. This is, let's say, 0/0, F0/0, and this is, let's say, F0/1. Here I am running network 192.168.10.0/24 and not /24, let's say 25. Here I am using /25, and here I am using network 192.168.10.128/25. See, both network are different, yes or no?
Same.
Both are different, brother.
192, 160, 10. Oh yeah,
Remember the
it's 25.
subnetting,
It's 25. Okay.
right?
Yeah.
So I want to enable EIGRP on these two interface. I will run network command. With the help of network command, we are enabling routing protocol on the interface. Yes or no? Either we can run network 0.0.0.0. It will enable EIGRP on all interfaces, right? Or guys, I can write what 192.168.10.0 and then I can define wildcard mask. If I will define this wildcard mask 0.0.0.255, now you tell me EIGRP will enable on which interface if I will run this command. It will match how many bits?
8.
It will match 24 bits now. 0 means match bit and
Okay,
1 means
okay.
ignored bit. As I told you, wildcard mask is apogee of subnet mask. So here we have 24 bits match. Yes or no?
Yes.
Means it will match these 3 octet. So 192.168.10.0 on any interface where you are running this network, router will enable RIP. Yes or no?
Yes.
Right? But with the help of single command, or let's say if I am writing here 128, so it will enable RIP on which interface? F1/0. Sorry, EIGRP on F1/0. Yes or no?
Yes.
It will enable EIGRP on which interface? You guys are wrong. You know, here I am writing 0, and if I am putting this wildcard mask, so EIGRP will enable on both interface. Because see now, it is matching how many bits? 30, so only 24 bits, and 24 bits is common in both network. So 24 bits is matching in this network also and this network also. It will
Sir,
enable EIGRP on both interface.
so I have a quick question.
Yeah,
192.168.10.0/25. This network in the other net are the same network or no different network?
different network,
Why is
brother.
different network the same?
No, see, this is network ID of first network. This is network ID of second network. You know, subnetting. Please remember the subnetting. This is concept of subnetting. The main network is 192.168.10.0/24, and I have divided this network into two parts. First is 192.168.10.0/25, and second is 192.168.10.128/25. This is second network. This is main network, and these two are subnetted network. Subnetting is dividing large network into multiple parts. So we have divided this network into two network. Here how many valid hosts are there? 254. Here how many valid hosts are there? 126. Clear?
Yes.
Yes.
This is single network, unsubnetted network, and these two are subnetted network. So if you want to enable EIGRP on both interface of this router, you can run this command. Network 192.168.10.0, and I can tell to this router, please match only these octet, means 3 octet. Okay. The another way, if I will run command network 192.168.10.0 and wildcard mask. This time I am going to define wildcard mask of /25. What will be the wildcard mask of /25? 0.0.0.127. Yes. Yes or no? Here you have calculated.
Yes.
255.
Now this time actually I am telling to router match how many bits? 25 bits. I'm telling to router this time you need to match
25 bit.
how many bits? 25 bits. So it will enable EIGRP only on F0/0. Here I need to run one more command, that is network 192.168.10.128 wildcard mask 0.0.127. Okay. So when I am writing this wildcard mask, it will match 25 bits. If I am writing this wildcard mask, so it will match only 24 bits.
So why we don't want use default like 000 wildcard?
0.0.0.
Yeah.
It will match all 32 bits.
So this is a
It will
default. You
match.
can use that one. It will automatically will on all routers, all interfaces.
Yes, you can use this also, but it will enable EIGRP on the exact interface where you are running this IP address. But this is network ID, brother. This is not the IP address.
All
What is the IP address of in this interface? IP address will be maybe 10.129.
Yeah.
So it will not found any match. If you will put all 0, it will look for 192.168.10.128, and 128 is not exist on router number 1. This is for IP address. When you need to advertise IP address, you need to run this wildcard mask 0.0.0.0.
We can do advertise this one in network ID, right?
Right.
Okay.
EIGRP and OSPF works on wildcard mask. So till now we have discussed that wildcard mask is opposite of subnet mask, and it is used to match number of bits. It is used to match number of bits. Let me take one more example here. Again, I have one router R1, and let's say this router have some interface R, and this router have some interface in this, and this. Okay, this is, let's say, 0/0. This is, let's say, 0/1. This is, let's say, 1/0, and this is, let's say, 1/1. Done. Here I am running network 10.1.1.0/24. Here I am running network 10.1.2.0/24. Here I am running network 10.1.3.0/24, and here I am running network 10.1.4.0/24. You guys need to practice subnetting if you have problem in these type of example. All networks are different or same? All networks are different, yes or no?
Different.
Now I want to enable EIGRP on all interface by running a single network command. What network command I can run? See, in all network, first octet and second octet is common, yes or no?
Yes.
In all network, first octet value and second octet value is common. So I can tell to router 1 network 10.1.0.0 and wildcard mask 0.0.255.255. Here I am telling, please match only 16 bits value, yes or no, and ignore the last 16 bits value. So first octet value should be 10, second octet.
Which
Yes.
network is that? 10.1.0.0. Where did you get this one?
No, I am advertising this network.
Okay.
Okay, this network is not existing on router definitely, but I am advertising a network and where match is only 2 octet. So router 1 will check in first octet value is 10. Okay, on which interface this network is running where value is 10 in first octet? Oh, these are the interfaces, yes or no? Then it will check second octet value. Second octet value is 1. So second octet value is 1 in all prefixes, yes or no? Then these are ignored bit. It is not going to check this bit, and it will on EIGRP on all interface. It will enable EIGRP on all interface because we have match only 2 bits, which are 2 octet, which are common in all prefixes. But if I will run command not like this. If I will run command like 10.1.1.0 and wildcard mask 0.0.255, this command will enable EIGRP only on one interface. On which interface?
Interface 10.1.1.0.
F0/0. On
Yes.
0/0 it will enable EIGRP only. If you are saying 2, so this command will enable EIGRP on F0/1.
0/1.
If I am typing 3 over here, so it will enable EIGRP on F1/0. If I am typing 4, it will enable EIGRP on 1/1. But if you want to enable EIGRP on all interface with single command, you can type 0 over here. And wildcard mask will be here 255. 1 means ignore bit. I have ignored how many bits? 16 bits. So it will match only 16 bits value. So if 16 bits value will match on any interface, on that interface, RIP will enabled.
Okay.
Sorry,
so-
EIGRP will enable.
Okay, so if you have like one interface is different, like 10.2.2.0, whatever, like that, then we can
Okay,
use
let's
like
say
10.00.
you have one more network,
Mhm.
and here you are running which network? 10.2.2.0.0
Mhm.
/24. This is
Yes.
or 10.2.1.0/24, let's say. Right now, if you want to enable EIGRP on all interface with single command, network and 10.0.0.0
Great, okay.
0.255.255.255. See, now in all the networks, first octet value is same. Yes or no?
Yes.
So it will match only 8 bits value. It will match only 8 bits value, and 8 bits value will match on all interfaces. So it will enable EIGRP on all interface, right?
Yeah.
This is how wildcard mask work. Okay, guys?
One more question. In
Yes.
same. Okay, if there's one network prefixes 25, 26, or 28, then how we gonna do that? We gonna do like manually that one, or no? We do on the same command.
Which network?
So let's do like one network is same as like 10.1.5.0 slash
5.0/24.
20, no, 26 or 25.
26. Yes, then also it will be same. Doesn't matter what network you are running. Actually, with the help of wildcard mask, you are telling to router that you need to match how many bits only.
Okay, the prefix is not important here, right?
Yes, prefix is not important
Right,
here.
okay.
Here important is I want to match how many bits. That's it.
Okay.
That is important. With the help of wildcard mask, we can match the number of bits.
Okay.
Okay. Like, let's say, let me take one example over here. 192 or 190, okay, 2.168, or let's say 10.1.1.0/24, then 10.1.2.0/24, and 10.1.3.0/24, and 10.1.4.0/24, and 10.1.5.0/24. We have this network. Okay. Now I am telling to Abdul, please, I am writing one wildcard mask here, 0.0.0.255, and my network ID is 10.1.1.0. 10.1.1.0. It will match which network, guys? Only upper network.
Yes.
10.1.1.0, right? If I am writing here 2, it will match second network. Yes or no?
Yes.
If I am writing 3, it will match third network. If I am writing 4, it will match fourth network. If I will write 5, so it will match fifth network. Yes or no?
Yes.
Because here we are we are defining that we need to match 14 bits. And now if I want to match all prefixes, so here I can put 0 or any value, doesn't matter, let's say 5, and I can tell in wildcard mask 255 here. So now I am telling to router, please ignore last 24 bits. So it will not check what value is there in last 24 bits. So it is matching in all network, right?
Yes.
So I am telling Abdul, please check this information and advertise the network from here, from this table. So Abdul will advertise all network because match is there of all network in this entry. Yes or no? This is the concept only. Getting my point, guys?
Yes.
If I'm saying wildcard mask 0.255.255.255, it will match only first octet value. If in first octet value is
All.
10,
All.
so it will advertise. And if here also, if I'm telling what 255, so it will not check anything.
Yes.
It will not check anything. It will advertise EIGRP on all interface. Getting my point?
Yes.
Doesn't matter. Now you have one network that is 20.1.1.0. So this network will also advertise.
Mhm.
Because here we are telling to router, do not check any bits. Fine.
Yeah. So
Now
if
one
Yeah.
more example.
yeah,
Yes.
so if you have like a same network like 20.1.1.0, then we cannot use like 10.0. Right? This one will be advertised different in different.
Yes, yes. Here, see, I have 10.1.1.0 and 20.1.1.0. So I will run
Yes.
network 10.1.1.0, or let me 10.1.1.0 wildcard mask 0.0.255. It will advertise this network only. If I will type wildcard mask 255, it will advertise again only this network. It will match only these 2 bits.
Mhm.
If I will set 255, then also it will check first octet value should be 10, and here if I will type 255, then it will not check first octet value as well. Doesn't matter what value are there. So it will
Mhm.
advertise both interface, both IP address, both
So
network.
so then we have to we need to do the this one right 255 255 255 255 right? Then
Right,
why we don't use
exactly.
this one?
If you want to so that will be our concern while understanding RIP or OSPF protocol.
Mhm.
When you need to run this type of command,
But it
just
won't
first
match.
try to understand the function of wildcard mask,
Okay.
why we have wildcard mask and how we are using wildcard mask.
Mhm.
Just try to understand this only for now.
Okay.
Got it? So in the whenever we will have this type of network, we will run command 10.1.1.0 wildcard mask 0.0.255, then 20.1.1.0 0.0.255, like this. Okay, brother?
Yes.
Okay. So now on this router, guys, on these 2 router, let me do one thing. I am going to remove which RIP routing protocol. So let me run no router RIP command here. No router RIP. And access control list also work with wildcard mask. Like we are running which protocol here? RIP, and do so access list. So we have one access control list 10 and 20. Let me say no access list 10 and no access list 20. I have removed the access list configuration from router number 1. Router, let me remove the filtering. Router EIGRP, sorry, router RIP, and no distribute list, access list number 20, and direction in. I have removed the filtering configuration. Now again router 1 will start receiving all prefixes. So IP route RIP. So it is receiving all individual prefix here. Getting my point?
Mhm.
Okay. And now see, if I want to filter all prefixes, all 10 prefixes, so I can create access control list number 10 and then network, let's say 10.1.0.0 and wildcard mask 0.0.255.255. See, it will in this entry all prefixes will match, yes or no? In this entry,
Yes.
brother,
Yes.
all, yes or no?
Yes.
So if I'm running command like this access list, and here I need to say deny. So if I will run this wildcard mask to deny the prefixes. And let me create one more access list permit any. And now distribute list, not here, router rip, and distribute list access list number 10 and direction in. Now you can see so IP route rip. After some time you will see router will filter these all prefixes. Router will filter these all prefixes. Wait. See here, timer is not resetting. For this prefix, timer is resetting. For these prefixes, timer is not resetting. So after hold on time, it will discard it. But I don't want to wait for hold on time. So what I can do, I can run shutdown command and no shutdown command on F0/0 shutdown, and then again no shutdown for the quick result. And so IP route rip. You can see router is receiving only this network information. Why? Because we have filtered all the prefixes. So access list. Here you can see this is the entry 10.1.0.0 and wildcard mask is 0.0.255.255. So all prefixes will match in this entry. Let's say I want to filter upper 3 prefixes only. I want to filter upper 3 prefixes only. So you need to perform the summarization. Let me remove this access control list first. Say no access list 10. I have removed this access control list. Again router 1 will start receiving all individual prefixes. So IP route rip. So soon it will see it is receiving all prefixes now. And now my concern is I want to filter only these upper 3 prefixes. Getting my point?
Yes.
So guys, you need to find the summary address of upper 3 prefix. You know how to find the summary address?
No.
No. See, summarization is nothing but summarization is opposite of subnetting. Subnetting is what? Dividing large network into multiple smaller network. And summarization is dividing a smaller network into single network. Let's say I want to summarize these 3 network together. Okay, I want to summarize these 3 network. So first of all, what I will do, let me copy it and let me paste it in Paint. First of all, if you want to summarize these 3 prefixes, you have to check value is changing in which octet. Actually, you need to find how many common bits are there in all network. How many common bits are there? So are you able to see first octet value? First octet value is 10 over here also, 10 over here also, and 10 over here also. Right? Means value in third octet is same in all prefixes. Yes or no?
Yes.
Value in first octet is same. Means all 8 bits is common in all prefix. Yes or no?
Yes.
8 bits is common. It is very clear. In second octet also you can see value is 1
Same.
over here, 1 over here, 1 over here. That means second octet value is also common. Means 8 more bits are common. Means total 18 bits are common till octet 2. Yes?
Yes.
Actually, I want to summarize these 3 prefix into a single prefix. For that, I need to find the number of common bits. So till now we are able to see 16 bits are common over here. And value in third octet is changing. Here value is 1, here value is 2, and here value is 3. Yes or no?
Yes.
So we don't know how many bits are common in third octet. Is it clear? So we will convert value of third octet into binary. So what will be the binary of 1, guys?
0, 0,
0, 0, 0. 1. This is binary of 1. Then we will convert binary of 2. 0, 0, 0, 0, 0. 1, 0. Then we will convert binary of 3. 0, 0, 0, 0, 0. 1, 1. So now you tell me how many bits are common in third octet?
5.
Uh,
6.
5,
6.
6 bits. Definitely 6. Because here in the 7th bit we have changed. Here value is 0 and here value is 1. Getting my point?
Yes.
On 7th bit value is changing. So total number of common bit is
6.
6 over here, 8 in second octet and 8 in first octet. So total common bits are, how many common bits are there total? 8 plus 8 plus 6. Yes or no?
Yes.
22. Am I right? And now you need to perform AND operation over here. If you will perform AND operation, so 0 0 0 0 will become what? 0 0 0 0 0 0 0 1 2 3 4. All value will become 0 over here after performing AND operation. Yes or no?
Yes.
Hope it is clear. Now you will convert this binary into decimal. So decimal value of this binary will be what? 0. So your summary address will be 10.1.0.0/22. This is the summary address of upper 3 prefix. Is it clear, guys?
yes.
Now, what will be the subnet mask for /22? 255.255.252.0. Okay, what will be the wildcard mask for this subnet mask? 0 dot 0 dot
0 255 minus
no
255 minus
50
252
3
3
dot
and
255.
255. That took 255.
Yes, this is the wildcard mask. So if I will, deny this network with this wildcard mask, automatically router 1 will filter upper 3 prefix. Let me show you. On router number 1, I am going to create the access control list 10 again. Now it is receiving all individual prefix, you can see. And here I am going to create access list number again 10 and deny. This time I am going to deny 10.1.0.0 and wildcard mask 0.0.3.3.255 and access list 10 permit any. This time it will match this entry. And tell me in this entry how many network will match?
First 3.
All upper 3 prefix, yes or no?
Yes. Yes.
So it will filter all upper 3 prefix. So IP route RIP. You can see router 1 have filter all upper 3 prefix. Here we have only 10.1.4.0. Now is it clear, guys? Wildcard mask.
Yeah.
Yes.
How wildcard mask is working? Actually, so access list. Here is entry. We have defined this network and this wildcard mask. So match the network from this entry and from here. Here we have defined that how many bits you need to match. How many bits you need to match. So in first octet you need to match all bits, 8 bits. So value should be 10. In second octet value should be 1. In third octet also you need to check some value. How many bits you need to match in third octet?
3.
3 or 5?
5. 5.
5. And all should be what? 0. You know why it have not filtered 10.1.4.0? The reason why router have not filter 10.1.4.0 is if you will convert 4 into binary. So binary of 4 will be what? 0 0 0 0 1 00. Yes or no?
Yes.
So see, guys, in 6 bits value is changing. Yes or no?
Yes, yes, yes.
So it wildcard mask tell to router 1 you need to check the 6 bits in last octet and all values should be what? 0. Yes or no? But in fourth prefix, this value is 1 over here. That is the reason why router 1 is not filtering the lower one prefix. Getting my point? Hmm? This is how wildcard mask work. Just I am trying to explain you wildcard mask. If you will have time, try to understand wildcard mask by yourself as well. You can use Google, Wikipedia, right? Chat GPT. You can watch my video. You can read book. Try to solve some questions of wildcard mask. Then definitely you will be master in wildcard mask. And once you feel that you are good in wildcard mask, you can understand access control list. I can make you understand the rot advertisement in EIGRP and OSPF easily. So there are lots of concept of wildcard mask in EIGRP and OSPF. Okay.
Yes.
Okay. And here let me write what is the difference between subnet mask and wildcard mask. So wildcard mask is similar to subnet mask in that it uses AND process to identify which bits of an IP address to match. However, a wildcard mask and subnet mask differ in the way they match binary 1 and 0. Okay, you need to read the detailed information with this link, then only you will understand. I am actually looking for the short introduction. Wildcard mask used to specify the range of network address, definitely yes, and they are commonly used in routing protocol like OSPF and access control list. Okay, subnet mask. Wildcard mask is in 32 bits long. It acts as inverted to subnet mask, as I already told you that it is opposite of wildcard mask. And here you can see, but in wildcard mask, the 0 bits indicate that corresponding bit position must match the same bit's position in the IP address. The 1 bits indicate that the corresponding bits position does not have to match the bits with IP address. Okay, so 1 means you don't need to match, and 0 means you need to match only. This is the difference. Is it clear?
Yes.
Now you tell me, you want to start EIGRP today or tomorrow?
We'll start it tomorrow.
Okay, now we don't have anything in RIP. We can start EIGRP tomorrow. Definitely it will be good. But now if you have any doubt, guys, anybody, you can ask. We have some time. We can discuss your doubt. If anyone have any doubt.
No, I don't have any doubt.
Okay, so you will also try to perform this type of practical, like try to filter the upper 3 prefix on router number 1, or you can create some loop back on router 1 also, like 20.1.1.0, 20.1.1. 20.1.2.0, 20.1.3.0, 20.1.4.0, and 20.1.5.0 and 20.1.6.0. Okay, so let's say router 1 have these prefixes. Okay, let me copy it also, and I have one router over here. R1, R2, and router 1 have, let's say, these prefixes. Okay, guys. with /24 /24 0 /24 /24 /24 /24 and /24. Now in these prefixes, let's say I want to filter some prefix. I want to filter some prefix to router 2. By default, router 1 will advertise all prefixes to router 2. Now let's say I want to filter prefixes from 20.1.4.0 to 20.1.6.0. Okay, I want to filter these two prefixes on router number 1. What command you will run? What will be your wildcard mask and what will be your network ID? If I want to filter prefixes from here to here,
We have to write summary. We have to delete.
yes, what will be the summary address of these lower three prefix, guys?
Yeah, we have to remove these two first. These two IP. 4
First
and
of
6.
all, you need to find the summary address.
Third octet.
First, summary address of these three network. So what will be the summary address of these three
1,
prefix?
2, 3, 5. Between 1, 2, 3, 5. We have to write them in binary.
4, 5,
0,
6.
0, 0, for the first one.
So you will
7.
convert 4 into binary, 5 into binary and 6 into binary only. Yes or no? You don't need to convert 20 and 1 into binary because 20 is common in all prefixes. 1 is also common in all prefixes. Yes or no? To summarize the prefixes, we need to check where value is changing. So value is changing in which octet? In third octet. So I will convert value 4 into binary. So binary of 4 is
0, 0, 0, 0, 0.
0, 0, 0.
1, 0, 0.
100. This is binary of 4. What will be the binary of 5?
0, 0, 0, 0, 1, 0, 1.
Very good. And binary of 6?
1, 1, 0.
Very good. So how many bits are common?
5.
Total how many bits are common?
15.
8 plus 8 plus
8 plus 8. Yeah, 8. In total, 8.
8 in first octet, 8 in second octet and 5 in third octet. Total is
21.
21. So slash value will be definitely 21.
20.
And here you will perform AND operation. After AND operation, what value you will get? 0, 0, 0, 0, 0, then 1, 0, 0. Yes or no?
Yes. It's
And
gonna
what will be the decimal value of this binary?
20.1.4.0.
Yeah, very good. 20.1.4.0 slash 21. This is the summary address. Yes or no?
Yes.
So actually you will deny this address. So what will be the wildcard mask? 20.1.4.0 and wildcard mask will be what?
0, 0.
0. 21 is 25, 20, the 255, 255,
248.0. Submit mask will be 248.
248. Okay, it's going to be 0, 0.
This is submit mask. Yes, 0.0 dot. Very good. 7.255.
255.
Right, if you will filter this address, so automatically lower three prefixes will filtered. Okay, now hope it is clear to everyone, and if you guys are able to answer, that means definitely is clear, but you need practice. Okay, so whatever things I have performed in the class, please try to perform by yourself. Okay, you can design, you can take other network as well at 50.1.1.1 or 10, 20, 192, 172, any prefixes. and try to filter, try to understand the wildcard mask practically also and theoretically also. Okay.